To use the ESP32 Cucumber development board, we must first install some additional board managers to the Arduino IDE. For that, we can go to the Files, Preferences, and paste the following link, in additional board manager URLs, and press OK. And then we go to Tools, Boards Manager, and in the search bar, type ESP32, and install the latest version. After connecting the Cucumber board, via USB-C cable to the PC, we must select the board, from the Arduino IDE. We can do that by going to Tools, and selecting ESP32S2 Dev Module, and selecting the appropriate port, in our case COM8. In this project, we are demonstrating two tasks, with two levels of priority. The highest priority task is updating the time with an NTP server every minute, and the lower priority task is displaying a local real-time clock every second on the serial monitor. We have assigned priority levels 2 and 1 accordingly. Let's see how the code works. First, the required libraries are included in the code. In this code we use Wi-Fi.h, Time.h, SNTP.h and ESP_SNTP.h libraries. In this project, we will connect to Wi-Fi, and get time from an NTP server to display local real-time clock. For that, we need to define the Wi-Fi SSID and password of the network to which we want our development board to connect. Then in the void setup, we write the code to set up the Wi-Fi connection. After that, we define a function to print local time, which configs its time information according to our country offset time and daylight offset, by getting the time from an NTP server. In this code we use two NTP servers, pool.ntp.org and time.nist.gov. The offset time for Thailand is UTC plus 7 hours. That is 3,607 seconds. There is no daylight offset for Thailand. We can easily find these values by searching on the internet. Next, we will add an SNTP sync notification callback inside the void setup named timeAvailable, and make a separate void function for it. That way it will print whenever there is an update from the NTP. Now we will create two tasks, X-task create task 1 to display real time. We will set the priority to 1, where priority 3 is the highest, and 0 is the lowest. X-task create task 2 to update time from NTP server. By default, the time is updated from the NTP every hour. In this project, we will reduce the time gap to 1 minute, and run it as a high priority task. So we will set priority to 2 for the task 2. Then, it will start to run the tasks as scheduled. After that, we need to define what happens in task 1 and task 2. In task 1, it will print local time every second. So we set the task delay to 1000 milliseconds. Task 2 will call the function SNTP sync time to update the time with the NTP every minute. So we set the task delay to 60,000 milliseconds. There is another way to update the NTP for a user-defined time. That is by adding SNTP_set_sync_interval 60,000. In the code we created a task because we need to set high priority for it. What the SNTP sync time function does is, it will update the system time by restarting the SNTP. So that's basically how the code works. Now we will upload the code to our ESP32 development board and see the results from the serial monitor. We can see that the ESP32 module gets connected to Wi-Fi and updates for the first time using the NTP and displays the time every second. Now if we wait 1 minute and see. We can see that the time gets updated with the NTP, which is why our callback function is called, and the message got time adjustment from NTP is displayed. So, that's it for today's video. Thanks for watching. See you soon with another video.